Hello. My name is Aaron Hoverston, and today we're going to be looking at a visual representation of completing the square. Throughout school, we really only look at it in a formula or an equation, and I wanted to help some of the visual learners or other people struggling to show what it looks like geometrically and visually. So, to start off, we're going to be looking at something I find super interesting, which is the relationship with perimeter and area. For example, we have this 1x9 rectangle. We know that the perimeter of that rectangle is 20, because 9 plus 9 and 1 plus 1, and we know that the area of the rectangle is 9. Now, what's really interesting about this is if we took this into a square of the same perimeter, which would be a 5 by 5, so the perimeter of the square is the same, but the area would change to 25. And real quickly, I'm going to move the string over just to show that I'm not messing with the shape of the squares or anything like that. Okay, as you can see, the string that was around the 1x9 rectangle still fits, so the perimeter is still the same, but remember that the area did change. And I always wanted to wonder, why is there this difference? Is there some sort of constant? Is there a way to figure out the distance mathematically? Stuff like that. And completing the square is the answer. So, for example, if your teacher gave you a rectangle and said that the black part represented the x's and the yellow part was a constant, then writing it over here, we would know that the short side is x plus 2 and the long side is 2x plus 4. And it is also given that the area is equal to 32. Now, working through this, what we're going to do is perform completing the square. And the first thing we have to do is set up our equation. So we know that length times width is equal to the area, or that 2x plus 4 times x plus 2 equals 32. Now what we're going to do is FOIL this out and get 2x squared plus 8x plus 8 is equal to 32. Now usually you would subtract the 32 over, set it equal to 0, and solve for x that way. But for completing the square, it's a little bit different. We want all the variables on one side and all the constants on the other. So we're going to get that 2x squared plus 8x is equal to 24. And personally, I like to make a lot of silly mistakes, and this a value could make things a little bit complicated. So I'm going to get rid of it and divide everything by 2 right away. So we're going to change it to x squared plus 4x equals 12. Now, the next step is the part that I always found confusing, because what you end up doing is you're going to add the number of the b value divided by 2 times the a value, which we got rid of. So right now it's just 1. And you're going to square it. And you're going to add that to both sides. And this is why I found it confusing, is why are you adding this number? It just seemed very counterintuitive to me to make the problem more complicated. But completing the square does have a reason for it. For example, for here, we get that x squared plus 4x plus 4 is equal to 16. And the part that's interesting is that this is a perfect square. For example, 25 is a perfect square of 5, and 5 times 5 equals 25, or 144 is the perfect square of 12, because 12 times 12 is 144. But it doesn't always have to be a number, it can be an expression. For this, it's a perfect square of x plus 2, because x plus 2 squared is this expression. And we have that equal to 16. And now solving for x, we have x plus 2 equals 4. Usually you would have a plus or minus, but since we're going to be looking at it visually and geometrically, and we can't have a negative distance, I'm not going to consider a negative solution. We're only going to look at the positive one. So we get that x equals 2. This is important because it helps us find the perimeter of the shape. So we know that the rectangle our teacher gave us is a 4 by 8 with an area of 32. And we can check this because 8 times 4 is equal to 32. So we know that the perimeter of this rectangle is equal to 24, 8 plus 8, and 4 plus 4. And we know that the area of the rectangle is 32. Going back to the beginning, we showed that a square and a rectangle with the same perimeter could have different areas and that there was a correlation between those areas. So if we were to do the same thing here and make the perimeter of a square the same thing, making the side lengths equal to 6, because the 6 plus 6 plus 6 plus 6 would equal 24, would have an area of 36. And this is where completing the square solves our confusion between the two different areas. 36 minus 32 is equal to 4, and that is what we end up adding to both sides of the equation. So if we look at this equation, instead of an expression equal to some number, if we look at it as a length times width is equal to an area, we see that we're adding on extra area. That is important because when you're taking a rectangle and changing it to a square will have a bigger area and you will need to add on area to make it a square. Hence the name, completing the square. So hopefully that helped you guys visually understand it, and thank you for watching.